Welcome students to your channel Pradeep Sir Classes as PSC where Logo can talks the physics. So today's the class is about classical text series long day after. So this is general physics i.e. Irodov solutions and this is chapter 3 question number 7 and question number 8. So for question number question number 7 and 8, you have to clear your concepts about vectorial form of Coulomb's law and as well as the continuous distribution of charge. So students, what is about continuous distribution of charge and the vectorial form of Coulomb's law? First of all, I want to make a video on that particular topic, that is continuous distribution of charge, and this is uploaded shortly. Okay, so starts with Coulomb's law, vectorial form of Coulomb's law, that is related concepts with question number 7. Okay, so take your copy and clear your concepts. As students, as I say, this is a numerical based channel, so if you fill in problems related with numericals, then obviously you have to stay with me. So Coulomb's law. Coulomb's law and vectorial form. Vectorial form. Students, Coulomb's law tells about the magnitude of 2-point charges. So if 2-point charges Q1 and Q2 are kept a small distance or large distance, it will be a specific range, and this distance must be greater than 10 to the power of minus 15 meter. Okay, what is about 10 to the power minus 15 meter? We know that from the fundamental law of electrostatics that like charge, that is a positive and the another positive charge, can repel this one, and if it is negative and the negative, then it is also repel, and if it is positive and negative, then attraction takes place. Okay, so when attraction takes place and when repulsion takes place, that depends upon the nature of the charge, and if it is in the nuclear range, that is if it is a nucleus, then the distance is 10 to the power of minus 15 meter, where a large number of protons can stay. So you can say that the two like charge cannot repel always. When the nuclear range is 10 to the power minus 15 meter, then it is bonding or force acting, binding force act, and this is called nuclear and this is called strong force. Okay, so this is a specific discrepancy, or this is a specific inconsistency with that particular law, that the distance must be greater than 10 to the power minus 15 meter, then Coulomb's law act, and the charge is always a stationary charge particle. Stationary means if the charge is moving, then we can take into account another chapter, that is current electricity. So for that particular one, you have to take a 2-point charge as a stationary point charge, and the distance must be greater than 10 to the power minus 15. Then we can say that F is proportional to product of their charges. So the magnitude of attraction and repulsion is directly proportional to this one, and this is inversely proportional to the square of the distance between them. And if we take a proportionality constant, then we can say that this is the formula, and by this formula we can calculate the force of interaction, that it may be attraction or repulsion between two stationary point charge. So this is the Coulomb's law, but this force, Coulombian force, is a vector quantity. So force is a vector quantity, so you have to write down a vectorial form. And what is about vectorial form? What is about vectorial form? This is the basic concept of Coulomb's law. And the vector, if the charged particles, students think about this is a charge and this is another charge, and they're kept at that particular position. So I think that this is the coordinate of this charge is suppose for taking that position. So for reach that particular position, you have to take first along this direction and then along this direction. So the coordinate of this chalk is x1 and y1. But that particular chalk is at x2 and y2. So the position is x1 and y1 with respect to this frame of reference. But if you take into account, then there are to specify that particular charge, you have to take another coordinates. Okay. So first of all, students, take into account coordinate system. That is, this is x-axis and this is y-axis. And a charge is given here. Suppose this is q1 and this is q2 charge. And the coordinate for that particular one is x1 and then y1. So the position vector, this is called position vector, this is r1 vector. So r1 vector equal to, we can write that this is x1 and this is y1. And then you get that particular, this is x1 and this is y1. So x1 and then I cap plus y1 and then j cap. So r1 is a position vector that can represent the position of charge q1 on a particular plane that is within the 2D. Similarly, you can represent the charge q2. The charge q2, you can represent the charge q2 at this position, and so this is r2 vector. And what is about r2? There is r2 vector, and this is equal to x2 I cap then plus y2 into j cap. Y2 into j cap. So this is the position vector where q2 is located with respect to this reference frame. With respect to this reference frame. And if you want to calculate the force of interaction between q1 and q2, then you have to take a line along this direction, because Coulomb's law acts along the line joining the two charge particles. Along the line joining the two charge particles. And so you can say that this force is F21. Why F21? Because this is the force experienced by 2 and Q1 give that particular force along this direction. So Q1 give a force of this one along this direction, so it is a vector quantity. And similarly we can say that Q1 can experience a force of this along this direction, because the force experienced is 1. And who give this force? So this is Q2 due to Q2. So you can write that F12. When it is written as F12, then you have to think the force Q2 given that particular 1 to Q1, and when 2 1, then force given 1 due and on Q2. So experienced is 2, and who give this force? So this is 1. So F12 and 21 are in opposite direction. So if you calculate this force, then you have to written as the force is 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught, and charge Q1 then charge Q2 by distance. What is the distance? So this is the distance between the two charges. This is the separation between the two charges. So when you have to take this value, and if you say that this is R12 vector, this is R12 means from 1 to 2, then you have to take a triangle, and this is the triangle. And if you complete this triangle, then you can see that these two are the taken as same order, and this is the opposite order, and this is the opposite order, and this is R2 vector, this is R1 vector, and this is R12 vector. So according to triangle of vector addition, you have to take these and these along same direction. So r1 vector plus r12 vector, and this is equal to r2 vector, and this is equal to r2 vector. So you have to record r12 vector. So this is equal to r2 vector minus r1. So students think about when you have recorded the position vector r12, then r2 minus r1. So similarly, when you have recorded r21 vector, then you have to write r1 vector minus r2 vector. R2 vector. When you have to record, you have recorded 1, 2, then r2 minus r1. And when you find that particular position vector, there is distance between them, the two are 1. So you have to subtract r1 minus r2. Okay. So here you have to calculate r21. So this is 1 by 4 pi epsilon naught q1 q2 by that particular distance. So r12. So you have written r12 vector and the mod value square. 1 by 4 by epsilon naught. It is the force is directly proportional to the charges, product of the charges, and inversely proportional to the distance. So distance, magnitude of the distance. So r12 mod value, and this is the modulus, and then square, and followed by unit vector, because it is a vector quantity. So what is about unit vector? So 1, 2, it is along q1 to q2. So r12 cap. R12 cap is the unit vector of 1, 2 cap. So here you have to write R12 cap. So the vectorial form takes a pattern, takes a form like that. If F21 vector, and this is equal to 1 by 4 pi epsilon naught, and you have to return this one as kappa. This one as kappa. But kappa is the proportionality constant, and this is equal to 1 by 4 pi epsilon naught, or 9 into 10 to the power 9. So this is into q1 q2 by r12 vector, and this is square into r12 cap. Or in place of cap, we know that a vector is a magnitude as well as direction vector. So direction vector means a unit vector. So unit vector, in place of unit vector you have to write vector by modulus. So in place of 1, 2 you have replace it by vector by mod value 1, 2, and this is modulus. So here it is 2, and this is also 1. So the equation is r12 vector and the modulus and then q. So this is the vectorial form. So this is the vectorial form. So F21 means the force experienced by Q2 due to Q1. That means Q1 give a force of Q2 along this direction with this magnitude as well as the direction vector. So similarly, students, when you have calculated, when you want to calculate the force experienced by Q1, then just change. In place of 1, you have to write 2, or in place of 2, you have to write 1. So the formula takes a form of 1, 2 vector, and this is equal to kappa, and then Q1, Q2, then Q1 into Q2 divided by R21 vector, and then modulus, then cube, and then R21 vector. So this is, but we know that the R21 vector is equal to minus of R12. So this force is equal in magnitude, but the direction is opposite. So it followed by a Newton's third law. Okay. So F12 vector is equal to F21 vector, but the direction is opposite. So you can write that F12 vector is equal to minus of F21 vector. So this is the vectorial form. This is the vectorial form, but you have to memorize in a shortest, in a tricky way, that when you calculate a 2-1 vector, the force experienced by 2 due to 1. So who experienced the force? So Q1 can give a force of Q2, that is 2 experience the force due to 1, and this is experienced and this is give the force. So when you calculate this 1, so you have to take a position of 1, 2, and 1, 2 is, what is about 1, 2? So this is R2 minus R1, and what is about 1, 2? So this is 2, 1, this is R2 minus R1. So when you write here 2, 1, then you have to take as 1, 2, and when you calculate this force R1, 2, then this is equal to R2 minus of R1. R2 minus of R1, you can get this one. And R2, 1, then R1 minus R2. So this is the 2, 1 and 1, 2 is the relationship. It is a very tricky concept and you can easily grab it. Okay, so next, go for the next one. That is the electric field due to a point charge, and you can take this into account that the first of one is the student, there is a charge and can create a field. There is a charge. If it is positive charge, then it creates a diverging field. What is about divergence? That is, it is outward direction. All the field lines are acted in the outward direction. But when it is a negative one, then the field lines is along this direction. That is inward. It is a converging field. So negative charge can create a converging field, whereas the positive charge can create a diverging field. Okay. So what is the intensity at a particular point? So this is intensity, electric field intensity is force by Q0. So what is about the charge Q0? What is the definition of Q0? So it is as small as possible, and the region of field of Q0 is very much negligible with a point charge, with respect to a point charge. So Q0 can create a field and Q can create a field. Okay. So Q0 is a very negligible charge, so it can create a small region within a specific region of field. Okay, so A equal to F by Q0, and here if we place a Q0, then the force equal to 1 by 4 pi epsilon naught into Q0 by, this is R square, if the distance between these one is R. So force equal to 1 by 4 pi epsilon naught into Q0 by R square, but if you divided this one, that is F by Q0, then you get a formula A1 by 4 pi epsilon naught Q by R square. So F by Q0 is the electric field. So electric field equal to 1 by 4 pi epsilon naught Q by R square. E equal to 1 by 4 pi epsilon naught Q by R square. Okay. So electric field, this is the electric field intensity somewhere within the field due to a point charge. But how you can calculate this one? You have to put a test charge Q0 within this field and you get the force. That is force per charge. It is called electric field. And this is the expression for electric field due to a point charge. Okay, I think it is clear. And the next one is, if this charge is somewhere and you have to take a frame of reference, then what to do? So students, this is a frame of reference. And the charge Q is given here, and this is the position vector. And so it is R1 vector. So it is R1 vector of charge. And you have to calculate electric field intensity at that point. So there is a charge and the position vector is R1, and you have to calculate electric field, that is R0 distance apart. This one is R0 distance. So R0 is the position vector of this, and here it is a point charge Q0, a test charge Q0. So the intensity at that point means this charge can give a force of on Q0, and this is the electric field intensity. So you have to write it in vectorial form. So electric field equal to electric field, that means force experienced by this one, and this one is, if it is say as 1 and this is 2, so according to the vectorial form you have to write as this is 2 1, so that this one is equal to 1 by 4 pi epsilon naught into Q into Q naught, but here it is F by Q naught means C, so you have to write only Q and the position vector. And what is about position vector? So this is from 1 to 0, so 1 to 0, 1 to 0, or 1 to 2. So 1 to 2 means 1 to 2. This is the position vector. So this is the position vector. So this one can get this one. So R0 minus R1. So R2 minus R1. Here R0 minus of R1. And this is the modulus. And this is Q. And then the vector, there is R0 minus R1. So this is a position vector. This is a position vector. So you can apply this one. And next one, students, so this is a concept of electric field, and here it is a vector quantity also. So the next concept is Irodov question number 7. What is about question number 7? So first of all, students, write down the question first of all and then try with the vectorial form, and it will be easy. If we apply continuous distribution of charge, or you can apply superposition principle, then it is very tough. So it is easy to be calculated this one, as if you take into account these numericals as a vectorial one. So question number 7, and point charge plus Q minus Q are located at the vertices of a square with diagonals as 2L as shown in figure. Find the magnitude of electric field strength at a point located symmetrically with respect to the vertices of the square at distance x from the center. Okay. So students, this is minus Q, this is minus Q, and this is plus Q, and this is plus Q, and this is minus Q, and this is minus Q. With a diagonal 2L. So students, this is the numerical, and the numerical is I think it is not an easy one, so there is a trick, and then it will get more easy. So you have to take a coordinate system. And students think this is x. So this is x, and the coordinate of this one is, so if I write this one with a tilde one, then it is minus Q here, and here it is plus Q, and this is along x-axis. This is along x-axis, and along y-axis this is plus Q, and this is minus Q. So this distance is L, and this distance is also L, and this distance is also L, and this distance is also L1. So I can erase this one. So this is a square. This is a square. Sorry, this is a square. This is a square, students, and the length is from this one is here. So coordinate of this one is, and you have to calculate a symmetric point. Suppose students, if you take a point at that particular one, here is the point, then the length of this chalk is x. So this is the distance x, and you have to calculate electric field at that point. Electric field at that point. So if I take a help of the pen, then you have to calculate electric field along this direction. So if we placed a test charge at that point, there is Q0, then these Q charge can create a field along this direction, and this one can create a field along inward, because since it is negative, and this one is also create a field along this direction, and this one is also create a field along this direction. So this is the direction, this is the direction, and this one is the direction, because it is a positive and this one is positive. So positive means this is the tip of the pen, so it indicates the direction of electric field. So this one is along this direction, and this is along this direction, and this will be these directions, and this is also be. So it is a very critical concepts, and if you calculate it with some particular force, this one and this one, then the resultant is along this direction, and if this one and this one along this direction, then you have to take this is the two directions, and you have to take along this direction the resultant of the electric field. So it is a very tough numericals. But if you calculate, suppose this is A, and this is B, and this is C, and this is D, and you have to calculate electric field C. So this is C. And what is about C? So it is so simple, 1 by 4 pi epsilon naught, and here it is a charge of Q and the distance. What is about the distance? So distance, the distance is, this is x and this is L. So this is x and this is L. So the diagonal is root over of L square plus x square. So this is root over of L square plus x square. So this is the magnitude, but you have to take it in vectorial notation. So 1 by 4 pi epsilon naught q by this to the power of cube. What is vectorial form? 1 by 4 epsilon q by r cube into r vector. What is the vector? So this is, the field is along this direction. So if I take this as one vector and this the two vector, then this is the resultant. So pen is the resultant, that is along z direction. This is x, this is y, so this is along z direction. So xz is the resultant. So this one and this one, and this is the resultant. So you have to take this one here. So it is this minus this. So it is, you have to write x z cap. So x k cap minus L, and this is along x axis, so minus of L I cap. So L I cap. Here is the direction along this direction, and this is, you have to take this direction chalk, then this is the x direction, so it is along z axis, since this is x, y, and this is z, so x k cap is the resultant, since these and these are along same order, and this is the resultant. So this one minus this one gives this vector. Okay, since it is plus and this one is a negative one, so E C equal to this one, and similarly ED equal to EC, ED is a minus negative one, so this is equal to also 1 by 4 pi epsilon naught and q by root over of L square plus x square, root over of, and this is whole cube, and the position vector is position vector. So this is x, this is x, and this is negative one, so this is the direction, and you have to take this one. So if I take this one, then this one is the resultant, and if we take this one, so this is x k cap, x k cap, and you have to take this one. So this is the resultant. So this one is a minus, this one is minus L into, this is along J, so this is minus J. So this is minus J, and this one plus this one is x k cap, and then this says the resultant. So it is, if I take, it is something, this is the direction. So this is, suppose it is a x vector, it is x vector, then this is minus of j cap, L j cap. If I take, this is the resultant, so this one plus x equal to minus of this. So this one is x vector equal to minus of L j cap minus x k cap, minus x k. So in place of here you have to minus of L j cap minus x k cap. Again, this is ECED, and then calculate EA. It is also along this direction. It is also along this direction. So this is the magnitude is same. The magnitude is same, and then this direction is x. This direction is x, and then z, that is k cap, x k cap. This one, then this one means, suppose it is y, suppose it is along z, so it is z vector. It is z vector. So this is z vector. So plus z vector, and this is equal to. So this one is a z vector, and sorry. This is x k cap. This is x k cap. So this is x k cap, and this is the plane, and this is the plane vector, and this is equal to this direction. So minus of L into I cap, L into I cap. So plane vector equal to, so you can write as, the vector is minus of L I cap, and then this one minus of x k cap. So this is the magnitude, and then you have to write this one, x minus of L I cap, and then minus of x k cap. And similarly EA is written, and then EB equal to, similarly this one, the magnitude will remain same, and this is along this direction. So if we take this is the vector, so it is, suppose it is L and j cap, and then the plane, and then this is the resultant. So this is equal to x into k cap. So the plane vector is x k cap minus of L j cap. So this is the direction. So you have to write here as x k cap minus of L j cap. So this is all the vector, and I think students, it is very powerful technique. This is a very powerful technique for calculating the electric field as a vectorial rotation. So then you have to add all the vector field, and then cancel some of the vector notations, and what is the remaining part is the answer. So if you take a common, you can take a common of this one, like M is the magnitude. So the resultant one is EA plus of EB plus of EC, and then ED. So then what is the main technique, students? First of all, you have to know that particular vectorial form, that is Coulomb's law. Then what is the vectorial form for electric field, and then apply this one. And you can take the magnitude as common, 1 by 4 pi epsilon naught, and Q, and then L square plus R square, and the root notation, and this is a cube, and then write down x k cap plus minus of L I cap, then minus of L j cap, then minus x k cap, then this one minus of L I cap, minus of x k cap, then plus of x k cap, and minus of L j cap. This is the answer. This is the answer, and you can calculate it easily, I think. So this is the final answer. X k cap and x k cap. This one cancel this one, and this one cancel also this one, and the remaining one is minus. You can take a common of minus, and then 2 of this one and 2 of this one, ing, and this is the final answer. And you can check. This is the most important, that is a classical text series, and this is general physics, and you can check 3.1, and you can check the answer, that is 3.1. So there is a page number, there is 93 from the page, and this is the electrodynamics. This is question number, yes, it is question number 7. Electrodynamics, and question number 7 is this is the 1 by root 2, so Q into 2 is the main, and so it is Q L square plus x square whole to the power 3 by 2. Okay, yes students, so this is the answer, and 2, and you can take as 2 root over of 2 L into L square. So this is the magnitude. What is the magnitude of this one? Okay, so students, this is the answer, and you can take as ing, and this is I cap and j cap at 90 degrees, so you can easily calculate that particular magnitude. Okay, so this is the final answer, and I go for the next one. That is question number 8. So students, again write down the question, and this will be more interesting. And if you suppose boarding that particular numericals, then you go ahead, and it will be a better numericals for that. Okay, so question number 8, and write down the numericals. And a thin half ring of radius r equal to 20 centimeter uniformly charged with a total charge q equal to this one. Find the magnitude of electric field strength at the curvature center of this half ring. Okay, so students, first draw and figure out that particular numerical. So it is a half ring. It is a half ring, and suppose the positive charge is distributed uniformly. Positive charge is distributed uniformly over the ring. Okay, so the numericals is distribution of charge is given 0.70 nanocoulomb. So Q equal to given, and R means this is the radius, this is 20 centimeters also given, so you can take this as 20 centimeter, or R you can take as R. And first of all, students, make a numerical relationship with variables, and then put that particular magnitude, and you can get easily what is the strength of this one. So students, we think that lambda is the linear distribution of charge. So lambda equal to total charge by total length. So total length is pi r, since the total ring is 2 pi r. So the total ring is 2 pi r. So half of the ring is pi r. So lambda equal to total charge by total length. And this is the radius. First of all, student, take a small portion and think this is dl. Think this is dl. Okay. So dl, what is the amount of charge contained with this dl? Obviously it is a small one. So this is dq, and the dq is lambda into dl. Why this is lambda into dl? Because lambda equal to charge density dq by dl. So dq equal to lambda into dl. What is the density of charge? So the charge is distributed uniformly over the ring. So dq equal to lambda into dl, and this amount of charge can create an electric field, can give a force of charge Q0 placed at that point. So this is a ring, and if we take a small portion of this one, then it can create a field. It can exert a force, electrostatic force on Q1 and along this direction, and we take this as dE. So this is dE. Why it is dE? Because it is also a small value. So dl, amount of elementary length of the ring, can hold a charge of a small value dq, and this is lambda dl, and that can create an electric field of dE along this direction. And if we resolute this one, so this is a theta something. So this is along a direction, and this is also perpendicular. So since this is theta, so this is theta, and you can resolute this one is dE cos theta, and along this one is dE sin theta. So this is dE cos theta, and this is dE sin theta, and if you place a mirror along this direction, then you can take another element as that particular position, and this element can also create an electric field along this direction. So this is also dE, and since this is theta, so this is theta, and this is dE cos theta, and this is dE cos theta, and along this direction it is dE sin theta. So all the dE sin theta can adapt to give a resultant force on that test charge placed at that point. So total electric field D is the integration of dE sin theta. dE sin theta. So what is the limit of integration? So this is 0 and this is 180. So you can take as 0 to pi. 0 to pi is the integration limit from this one to this one. But what is the value of dE here? So dE equal to dE, and this is equal to 1 by 4 pi epsilon naught into dq. dq is the amount of charge. dq by, this is the distance r, dq by r square. So this is the expression for point electric field due to a point charge. So this is integration of 0 to pi and dE. dE means 1 by 4 pi epsilon naught into dq by r square, dq by r square, and then sin theta, and then sin theta. So students, this is, since this is theta, then if we take this elementary portion, so this is d theta, this is d theta, because it is dl, so the angle subtended at here due to this element is d theta, and we know that angle equal to arc by radius, dl by radius. So this is arc d theta. So in place of dl, you can write arc d theta. So what is about dq? dq equal to lambda into dl. dq equal to lambda into dl. So this is integration of, so this is, where is my duster? So I can erase that particular portion, and this is electric field is equal to integration of 0 to pi and 1 by 4 pi epsilon naught, and dq is equal to lambda dl. So lambda dl by r square, and this is sine theta. This is sine theta. So lambda is a constant value. This is charge density. Lambda is charge density, and 4 pi epsilon naught is also a constant, and this is r square is also a constant, and dl equal to r d theta. So in place of dl we can write r d theta and sine theta. Here it's also given sine theta, and this is integration of 0 to pi. So 0 to pi, and then we write as lambda by 4 pi epsilon naught, and r cancel, so it is r, and integration of sine theta and then d theta, and the limit is 0 to pi. So lambda by 4 pi epsilon naught into r, lambda by 4 pi epsilon naught into r, and the sine theta d theta. So what is about the integration sine theta d theta? Then it is, you can say that this is minus cos theta. So minus cos theta. So theta here you have to limit, upper limit minus lower limit. So cos pi minus of cos 0. So cos pi means it is minus 1. It is minus 1, and cos 0 is also minus 1. So minus 1 minus 2, and then minus plus 2. So this is electric field E equal to lambda by 4 pi epsilon naught r into 2. So this is 2 lambda by this one. So 2 lambda by 4 pi epsilon naught r, or you can simply write as the electric field E equal to 1 by 2 pi epsilon naught. 1 by 2 pi epsilon naught, 1 by 2 pi epsilon naught, and then density divided by radius. And you can memorize this formula. If there is a ring of radius r, and if the lambda linear density is given, then you have to take this value lambda by r, and then multiply it with 2 into 9 into 10 to the power 9. Why? Because if you place this one 2, and you can take as 4 pi epsilon. So 1 by 4 pi epsilon naught means 9 into 10 to the power 9, and then you can easily calculate it as 2 into 9 into 10 to the power 8, and 10 to the power 9. So 1 by 2 pi epsilon naught and lambda by r. Here r is given. So the final value, numeric value, you can calculate numeric value as 1 by 4 pi epsilon naught. Then you have to multiply here 2, and this is 4 pi epsilon naught. So 2 into 9 into 10 to the power 9. Yes, and the lambda. So lambda equal to total charge by total, that is pi r. So total charge is given 0.7 nanocoulomb. It is given, that is 0.7 nanocoulomb. So 0.7 into 10 to the power minus 9 is the nanocoulomb divided by pi r. So pi r is given, and here is also you have to write, so pi r square, and r is also given 20 centimeters. So 20 by 100. So 20 by 100 in place of r you have to write 20 by 100, and this is a square, and this is Newton by Coulomb. So this is the answer, Newton by Coulomb. Students, and if you think that it is a more conceptual channel, then you can comment me and make your suggestion and what to do for the next one. And if I clear your concepts, then obviously comment me, then wow, what a concept. Otherwise you can also suggest me how to the realization is better. So it is given E equal to Q by 2 pi r square epsilon naught r square. So this is the answer, and this is 0.10 kilovolt, 10 kilovolt by meter, or Newton by Coulomb. Okay. You can use any one of the unit given here. So this is about question number 7 and question number 8, and I do that all the numericals are on the concepts of the continuous distribution of charge. So students, you have to realize that particular one, and if you think that I can't understand so properly, then you have to clear the basic concepts related with electrodynamics. Okay, so clear your concepts with electrodynamics from your tuition teachers, from your school teachers, or with the help of book, or you can follow my channel, and that is given the concepts of Coulomb's law, what is about Coulomb's law, what is about field, what is about Gauss's theorem, and when all the concepts is clear, they can easily realize that particular one, I think. So stay with me, and last of all, continue your study. Thank you.